All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 42's on the screen. You notice I moved a couple things around, removed some other things, and we're getting really close to beginning our journey with functions and graphing, your favorite. Let's go. So I'm going to give you extra practice on the warm-ups with that. So I'll give you a couple minutes, and then I'm going to go over each component just to make sure we got it, and we'll go from there. All right. Here goes number one. See if you remember. Compound inequalities. When we have a compound inequality where both graphs intersect in the center, who remembers the name of those? Me, Mr. Q. All right. These are known as what? And compounds. And how do we write the compound inequality? Well, you start with the points over here. They're known as dividing points. So what is my dividing point on the left? We got -1, -2, -3, -4. On the right side of 0, we got 1, 2, 3, 4, 5. We got X in between, arrows to the left, and question. Is this a solid point? Yes. Is this a solid point? Yes. And that's our compound inequality. However, did we stop there? No, we wrote our solution set. Solution set of X such that, and you close it. Coming back, yes? All right, good. It should, because this is coming back, guys. We're going to be using this pretty soon. Number 2, what's our common denominator, everyone? 6, that is correct. So distribute that to all the numerators. I'm going to go this way. So this is 12x over 3 plus 6x over 6 plus 6 over 6 equals to -12 over 3. And now we can simplify. So what is 12 divided by 3? That's 4x. 6x divided by 6, that's 1x. 6 over 6 is 1. -12 divided by 3, that's -4. I'm going to continue over here. 4x plus 1x plus 1 equals -4. Can I combine stuff? Yes, that's 5x plus 1 equals to -4 minus 1. 5x equals -5. Divide by 5, x equals -1. And have you got that by yourself? Okay, good. All right. Let's go to the last one. And I'm going a little bit more expeditious with this because we need all the time in the world, because today we're moving on. And I just want to make sure I have all the components before we move on to the next portion. Now, what do you guys notice different from these than the ones that we did in the past weeks? That it was y equals 2, is that correct? So before it became this, it should have looked like this. Look up. Y equals 3x minus 2. So what's the difference, Mr. Q? The only difference is that we replaced the y with what? F of x, because we're moving into functions. That's why this is known as a function. Okay. So I'm just giving you a quick intro. We're headed that direction. But here's the instructions. It says, evaluate the function of the graph using the domain -2, -1, 0, 1, and 2. Let me show you. My first value is -2. So everywhere there's an x, I put a parenthesis, and I'm going to substitute what value? -2. The left is just a label. Label. It's not a multiplication. It's just a what? A label, like an icon, if you want to call it, which means that stays the same. What is the only side that simplifies? The one on the right. So, what is 3 times negative 2? Negative 6 minus 2. I bring down the f minus 2. Next, f minus 2. Oh, sorry. F of negative 2. So what is negative 6 and minus 2? That's negative 8. That's how you evaluate a function. Let's do the next value. I'm going to switch to red. Negative 1. So I write again f of parentheses 3 parentheses minus 2 and substitute which value? Negative 1. And once again, the left side is known as our what? Our label, telling us what we're working with. That stays the same. So, what is 3 times negative 1? Negative 3 minus 2. What is negative 3 minus 2? Negative 5. Next, f of 3 parentheses minus 2. Next value is 0. F of 0 is, what is 3 times 0? 0 minus 2. So f of 0 is negative 2. And the last two, I'm going to go to green for my next value, which is 1. F of 3 parentheses minus 2. And we're going to substitute the 1. The left side stays the same. 3 times 1 is 3 minus 2. So f of 1 is 1. And last but not least, the 2. F of 3 parentheses minus 2. We substitute the value of 2. The left side is just our label. 3 times 2 is 6 minus 2. What is 6 minus 2? 4. We good? From 1 to 5, I'll come prepare you with that? Yeah? And once again, some of you already saw this. This is just, I'm bringing it back because we're going to be using it a little bit more. All right? So, copy the agenda, warm-up number 42. We're moving on now to 2 variable equations, so we do need a fair model. And tonight's home play is only 10 problems, only. And yes, we're starting graphing today. Oh yeah, let's go. Let's go. All right, we good? So, code for your home plate tonight, ready? 3px 5b, 3px 5b, 3px 5b. Make sure you get through those 10 problems. What's the word I'm thinking about? Oh, perseverance. Ha, 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 ha. Let's go. Yes. Look at the home plate. Let's go. Oh, yeah, we got this. Brandon. Let's go. All right, here we go. I can define and graph 2 variable equations. I can define and graph 2 variable equations. I can define and graph 2 variable equations. So we've been working with numbers from the beginning of the school year. We went to expressions. We went to some equations, but we went back again to expressions, which were the rationals. And again, we finished off with equations with rationals. And now we're moving on to 2 variable equations. I'm going to start slow. Today's the lesson that's more like a review for all of you, I hope. But I just want to touch on a couple things before we get started. So in your fair model, where you're going to write 2 variable equations, write this down. What are they? 2 variable equations, self-explanatory. Tell your neighbor a definition for 2 variable equations. Definition for 2 variable equations. I think Anthony D's got it, very good. Noah's got it. Jaden's got it, all right, Jaden. Kimberly, all right. Definition for a 2 variable equation. Well, Some of you went, an equation with two variables. Yeah, I get that. But here's my definition. Two expressions that are equal to each other and contain two unknown variables. Two expressions equal to each other and contain two unknown variables. Two expressions equal to each other containing two unknown variables. Examples. 3x plus 6 equals 3y, 12x equals 4y minus 8, 2a plus 2b equals 14, negative 3n equals m minus 6, and y equals x squared minus 9. All those are examples of two variable equations. Now, as you're copying, let's see. According to the definition, it says two expressions equal to each other. Well, let me see. Let me move this up a little bit. Let's see. This one. Is this an expression, 3x plus 6? Yes. How about the 3y? Yes. Are they equal to each other? Yes. How about this one? 12x is an expression, 4y minus 8 is an expression, and they are equal to each other. Okay. Expression, expression, equal. Expression, expression, equal. Expression, expression, equal. And what else does it say? Containing what? Two unknown variables. X, y, a, b, n, m, y, x. Yeah. Straightforward, yes? Yes, Mr. Q, thank you. You're welcome. Non-examples. As you're copying those, think about it. Why are those not two variable equations? Tell your neighbor why those three are not two variable equations, please. All right. Let's see. David, why is the first one not a two variable equation? I'm sorry? Oh, yeah, so it's not an equal sign and doesn't have two different variables. All right. How about the second one, Martin? Doesn't have two variables? Oh, how about the third one? Pass someone, Martin. Who? No equal sign. It's got a what? Inequality. So what would we call this one? Tell your neighbor. All right. Courtney, Jean, what would we call that? Yeah, two variable inequality. That is correct. We're headed that way. We're not there yet, but we're getting there. Hashtags, write these down. They need to have an equal sign, and also they need to have two unknown variables. Okay? Yes, Mr. Q. All right, good. All right, so where are we headed? Look up. So, for two variable equations, this is what we're going to cover. Look up to the screen. Don't copy this. I'm going to give you different forms, and once again, you should have already covered this in the past. I'm just reviewing with you, and I'm bringing them back. Your teacher should have taught you slope-intercept form, yes? Also, standard form, and right now we're talking about linear equations. And the last one, point-slope form. Slope-intercept form, look up to the screen, looks like this. Y equals mx plus b. The plus b is known as the Y-intercept, whereas the m is known as the slope. Today we're going to be working with these, and they're going to be looking something like this. So, turn to your neighbor, let them know the slope of that equation and the Y-intercept. what is the slope, and what is the y-intercept? All right, what is our slope? Brandon, Felix. 3, hands if you agree with 3. That is correct. That's how we need to have it in that form so that we know what the slope is. The second form looks like this. AX plus BY equals C. This is known as standard form, and what is so particular about that, Mr. Q? That both X and Y are on the same side of the equation. Bah. For example, 4x plus 6y equals 23, Michael Jordan. If I was to ask you what B is, you would tell your neighbor what B is. Tell your neighbor what B is on that equation. What is B, everyone? 6. That is correct because it's in standard form. We can match it up. There it is. The last form that we're going to get to is point slope. Looks like this. Y minus y1 equals m parentheses x minus x1. Does that look familiar? Kind of, sort of. But we'll get there when we get there. All right? I'm not going to give you an example because we're not there yet, but we're going to be working with these two, but mainly today with slope-intercept form. All right? So what are we looking at today, Mr. Q? We're looking at a quick intro to slope. I'm going to be focusing on slope. But before we focus on slope, we need to know where graphing comes from. Well, there was this mathematician named Michael Jordan. Yes, did you guys know that that's his favorite subject? Yeah. Michael Jordan's favorite subject is mathematics. Let's go. There was another mathematician, French mathematician. His name was Descartes. And Descartes figured, well, we can plot numbers on the number line, but if I want a different variable, maybe if I put another number line above it and plot it in another line. But people were getting confused when they stacked number lines over number lines. So he said, wait a minute, wait just a minute. What if I do this? Let's go. So he introduced a second quadrant or a second axis. This is the x-axis, and if he rotated counterclockwise, all these positives now are here, and he labeled this the y-axis. Rotating these down here, and these became negative, and once again, this is part of the y. And that's why we call this the Cartesian plane. Why? Because the mathematician's name was Descartes. So whenever I come up with something brilliant in mathematics, you're going to call it the Q whatever. Yeah? So make sure people don't steal my ideas. All right? So here we go. Quick intro. Google Maps, look up. Yes? That look familiar? Yes, Mr. Q. All right. So this is Imperial, and the high school's down here. Everybody see that? Yeah? So sometime back, there was a family that moved to Imperial, and as I was leaving campus, they stopped me and they're like, excuse me, Michael Jordan. Oh, no, I mean, excuse me, sir. I need to register my daughter at the middle school. I'm like, oh, the middle school is over here. Thank you, Ariana. The middle school is over here. So I showed her with my phone, and I brought up Google Maps, and I said, it's up here. You guys see it? And she said, oh, okay. I'm also get in your car. She was over here in the parking lot by the, over here by the staff. And I said, just get on your car and drive through these homes, and you'll get there very fast. No, we don't give directions like that, my goodness. So what kind of directions did I give her? Well, I said, you know what? I have a master key that opens the gate here for the gym and the cafeteria and all the way to the end. So you can just drive here, but you're going to go that direction. She's like, oh, okay, I see it. So she got her Google Maps. You're going to go 1 street, 2, 3, 4, 5, 6, 7 streets up. And then you're going to make a right turn. You're going to go 1, 2, 3, 4 streets to the right. Or R, I'm going to say. So I said, that is how you get to Frank Wright. And that, guys, is what we call the slope. 7 over 4. This is known as rise over run. Does that sound familiar? Yes? Good intro? Thank you, Mr. Q. Yeah, you're welcome. Gotcha. All right. So, rise over run, we got it. It's a fraction, and it gets us from point A to point B. So this is what I want you to do. Underneath your Frere model, get a coordinate plane. Oh, I got some steps, but you don't need the steps. We're going to go through the process. Make a coordinate plane from -8 to 8 underneath your Frere model. And we're going to do this one together to make sure we got it. Copy and go. I'll give you some time. Example Q reads, identify the slope of the line that passes through points -4, -1, and 4, 3. -4, -1, and 4, 3. So, for those of us that forgot, let me put the cheat code over here on the top. Whenever you are given a parentheses with two values like such, that's a coordinate. The first value will always be x. The second value is always y. So, with that said, students, I'm going to switch to blue. My first coordinate, we got -4 of x and -1 of y. So let's go to -4 of x. -4 is right here. -1 of y is right here. And where do they meet up? If I go straight to the left from -1 and down at -4, my first point is right there. Next, let's go to the second one. 4, +4 of x, and 3, +3 of y. 4 of x, +3 of y. Where do they meet up? Right there. All right, to find the slope, connect these two points. Imagine the lady driving to the homes like that. So, is that how we drive from one point to the other? No, we need to go rise over run. So I want you to do this, right on the side, M for slope, and then write rise over run. So M equals, let's go with the rise. Here we go. So how many steps up from here to match up to where we're going to make a right turn? Let's see. 1, 2, 3, 4 steps up, yes? So that's our rise. Then I make a right turn, and then I go 1, 2, 3, 4, 5, 6, 7, 8 of the run. Can I simplify this fraction, guys? Yes? Divide by 4, so it's 1 over 4. So my new slope is 1 over 4. From 1 to 5, I'll come to argue with that. 5, yes? So review. Let's do another one. Let's see. Copy this one. Example super Q, -2, 6. And 2, 3. If you want to use the same graph that you already used, the coordinate plane, that's fine. You don't get confused. If not, make a new one. Go. All right, let me plot this. -2, 6. -2 of x. 6 of y is up here, so it matches up about right there. It's frozen. Let it go. Let it go. I wonder if it's the nice, cool weather in here. Anyway, so you're like, it's cold in here, Mr. Q. Really? What? What? 2, 3. 2 of x, 3 of y, right there. Connect those dots. And remember, whenever we connect points, we always go from left to right. From left to right. Some of you are like, I can just go from right to left. How about that? Yeah, but whenever we read graphs, we always go from what? Left to right. So, let's see. I'm going to write m equals rise over run. M equals, let's see. What was the rise? Going from left to right, do I go up? No, I go down 1, 2, 3. Now look up, guys. If I go down, then it's not a positive step. It's a what? Negative. So this would be -3. Keep that in mind, please. -3. And then from there, we make a right turn. And then we go from here. We go 1, 2, 3, 4 to the right. And can we simplify that anymore? No. So my slope is -3 over 4. Pretty straightforward, yeah? Yes, Mr. Q? All right, good. All right, so I think we got a good intro for a rise over run, yes? All right, so make another one of these, please. Another one. And for this next one, let's do example, oh, I know. Your favorite. MJQ. Let's go. MJQ. But this time, instead of giving you 2 points, I'm going to give you a line. How about them apples? How about them apples? Yep. All right. Graph that line. You're like, okay, how do I do that, Mr. Q? Well, let me give you some points of reference. Use this point right here. -6, -2. You guys see it? Yes? And use this one over here. 3, 4. 3, 4. To graph your line. So I zoom in. Like so, yeah? Like that, yeah? All right. So, let's see. What points did we use? We used this one. This is -6 and -3. And this one is 3, 4. Yeah? Did I make the mistake? Oh, -6, -2. My bad. My bad. Yeah, I did that to see if you were paying attention. Which you were. Very good. All right. So, notice on this one, this is a little different. And I'm going to ask you for the slope. What is my slope? Tell your neighbor what to do if they give you a line and they ask you for the slope. What did you do? What did you do? What do we do? Looks like Anthony E's got it. Anthony E, what do we do to find our slope? You count, yes. Rise over run. You said 10 up, let's see. Oh, count up, okay. So if we go from left to right, yeah, it looks like it's going up. So let's do 1, 2, 3, 4, 5, 6. All right, so my slope starts with 6 on the rise. And then what do? I go to the what? Right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Therefore, tell your neighbor the slope. What is the slope of that line? Slope of that line, Jaden. 1/3. Hands, have you got that? That is correct. No? Jaden, did you say 1/3? Oh, he said 2/3. My bad. 2/3. Hands, have you got that? All right. So what is the process if I was to give you a line to find the slope? Well, first, Mr. Q, I need to place 2 points on the line and then find the slope. So, check this out. What if I use these? Look up, look up. What if I use this point and this point? What do you think the slope will be between those 2 points? Let's find out. I'm going to go up, 1, 2. To the right, 1, 2, 3. So my slope is 2 up, 3 to the right. What do you guys notice? It's the same. Why? Because it's the same line. So any line, pick 2 points, find the steps up or the right, steps to the right, which is the run of those 2 points, and that's going to give you your slope. From 1 to 5, how comfortable with this review? Good? All right. So, let me show you something really quick. Look up. Let me erase some of this stuff. Writing utensils down. Look up to the screen. Watch. We said that the slope for that line was 2/3. Is that correct? And the 2, we went up. Question, which axis goes up and down? Which axis? The Y. Okay, so let's look at these 2 points. Look at the Y values. Tell your neighbor what we can do with those Y values to give us that. Bless you. Hands if you see it. All right. What do we do to get that number with those 2 values? Anthony D. I'm sorry? Subtract. Okay. Let's see if it works with the run or the X, because the X-axis goes to the right. So look at the X values. Does that apply to that? Pretty much, yes? Okay. So, copy this one, blank like that. No tallies, no numbers. All right, place a point here and a point there. Connect the 2 points. All right, so let's see how we do. Ready? Y'all ready? So I'm going to label this point in the coordinate. That point is X, Y. So I'm not going to use numbers right now. I'm just going to use labels. So this is X, and this is Y. This point, I'm also going to label it X and Y. X, Y. Wait a minute. So on a different paper, if I was to give you x and y, do you know which point would be which? No, right? Because don't they look the same? So how would we distinguish this point from that point if we were to read graphs from left to right? Do you agree that this is the first point, reading it from left to right? Yes, so then I'm going to label this one x sub 1, y sub 1, x sub 1, y sub 1. This being second point, I'm going to label x sub 2, y sub 2, x sub 2, y sub 2. All right? Keep that in mind because we're about to find the slope. So look up, writing utensils, down, check this out. Let's say this point had the value to, give me a number, 3. All right. And this point had the value 4, and give me a number, 8. So question, look up please. To go from here to here for the slope, that means I need to go upward, is that correct? All right, so I'm at 3 right now, and I need to go to what? So how many steps? Tell your neighbor. 5. All right, don't copy that, you're just paying attention. Now, tell your neighbor what to do with these two numbers in order to get that 5. What do we do, everyone? All right. So, for the run, if I was to turn right to count the steps that way, this point is at 2, and we're going all the way to what? So how many steps? What do we do with those two numbers? All right. With that said, here we go. To find the slope, we have rise over run. Is that correct? So, to go from here to here, what would I write to get 5? 8 minus 3. Is that correct? For the run, to go from here to here, what would I write? 4 minus 2. Okay. But wait, I don't want that. I don't want numbers. I want my labels. You're like, what? Here we go. To go from here to here, what do I need to do with these two values? So what do I write? Let's go. That is correct. Write that down, please. Which means that the run, what would I write for the run, guys? Yes, write that down. And this is your formula that you're going to use for the home plate to find the slope. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Yes, we got it? Yes, Mr. Q. Do you know where it comes from now? Yes, good. Hopefully you learned that before, and this is just a review. If not, students slope, slope, students. Shall we? Copy this, example 3, Q. And it reads, find the slope of the line that contains 2, 5, and 8, 1 without graphing. Bah! Without graphing. Find the slope of the line that contains 2, 5, and 8, 1 without graphing. Let's do this one together. Like I said, this is review, but I'm going over it step by step to make sure we got it. To find the slope, first you label your points. And since we read from left to right, point 1 is this one, and point 2 is this one. So I'm going to label this one x sub 1, y sub 1, which means this one is what? X sub 2, y sub 2. So step 1, you label your coordinates. Step 2, write your formula. m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Are we doing good? All right. Next, I'm going to write it underneath, but without those labels. I'm just going to leave the negatives on the numerator and denominator. Now be careful with this step. This is a process that some of you made a mistake with in the past because you forgot to put the negatives before you substituted. So here we go. I'm going to start with red. Ready? Here we go. Y sub 2. Where's y sub 2? It's what? 1. Y sub 1. What is y sub 1? 5. Next, x sub 2. X sub 2 is, what? 8, yes? Goes right there. And x sub 1 is 2. All right, let's see. What is 1 minus 5? That's negative 4. What is 8 minus 2? That is 6. My brain's going a lot faster than me. Therefore, can I simplify this fraction? So the slope is negative 2/3. Woo-wee. Process, once again, step 1, label your points. Step 2, write your formula. Step 3, write the formula without the labels but with the negatives there. Then start your substitution. So, from 1 to 5, I'll come to you with that. 5 fourths, okay, let's do 1 by yourself. There it is. Example 3 super Q, -2, -2, and 7, -2. I'll give you a head start. Go. All right, here goes the process. Make sure you got it. Look up to the screen. Label each point. Set your formula. Third step is crucial. You should have written a negative there and a negative there before you substituted. If you didn't, you made a mistake. Here we go. What is negative times a negative right here? That's a positive. So 2 minus 2 is 0. Here, negative times a negative is a positive. 7 plus 2 is 9. But still, my slope is 0. Hands if you got that? Yep. Once again, be careful when you substitute. If you go from the formula here, make sure you write your negative above and below the fraction. From 1 to 5, I'll come for you with that. Yeah, we got it? Okay, so that's going to be the first, I think, 8 problems of the home plate, something like that. Let's go to the next part. Look up. Copy this one. Find the slope of the line given, 4x minus 2y equals 16. Find the slope of the line given by 4x minus 2y equals 16. Now check this out. I've been prepping you all along. You're like, what? Yeah. On the warm-ups, I kept saying, giving you stuff like that, and it said, solve for y. Solve for y. Tell your neighbor what to do in order to solve for y. What do I do? What do I do? Get rid of x, yes? So, minus 4x minus 4x. We got negative 2y equals negative 4x plus 16. What's my next step? Divide by negative 2. Divide by negative 2. Therefore, y equals 2x minus 8. Therefore, once you get to that form, you write underneath y equals mx plus b. Therefore, tell your neighbor the slope of that equation, that line. Everyone. 2, yes, because it matches right there. Or you can write it in fraction form, 2 over 1. All right? Next. Hold on. You're going to have some more of those. I think one extra one. And the last one. Look up. I'm going to give you one that looks like this. They're going to ask you to graph a line using the intercept, but they don't give you a slope. Tell your neighbor how you're going to find the slope for the line given that. Yeah, get your formula going, get the slope, and that's how you graph it. Good one, guys. Enjoy your home play. See you guys tomorrow. Bye.